when you have ax squared plus bx plus c type of expression where a is not 0, a is not 0 when we say, it means x square must live. It should not be vanished. And if a is not 0, x square will live. So this is obviously a polynomial, and this polynomial has highest power on x equal to 2. Then this polynomial is called quadratic polynomial. You can call it quadratic expression, you can call it quadratic function, but don't call it quadratic equation. Equation means it must have two sides, left and the right sides. If we put equal to 0, then this is now equation. And this is a quadratic equation. You have to be very clear about the distinction in the two things, quadratic expression and quadratic equation. And also inequation, if I may add, inequation. Well, that's also we will be discussing. So if you like, make the title even bigger: quadratic expression, equation, and inequation. You have already been dealing with inequation, and we discussed the wavy curve method in that context. Now that will be much more elaborate. An expression has got zeros. Zeros of an expression are those values of x that make it 0. So if alpha is the 0 of the polynomial, then if I put alpha here, automatically it will become 0. When we talk about equation, then we rather call it root. So if alpha is the root of the equation, then it would mean that it would satisfy the equation. So when we say quadratic expression, we don't use the word root. Don't use the word root for expression. Root word should only be used for equation. In case of this, you know what are the roots? They will also be the zeros of this. Minus b plus minus root b square minus 4ac upon 2a. That thing. So those are the two roots of this equation. There is no rule that the positive one must be called alpha or the negative one must be called beta. Nothing like that. So one of them is normally called alpha and other one is normally called beta. Most of the times people may prefer to use plus for alpha, minus for beta, but there is no hard and fast rule. In fact, there is no rule to call them alpha and beta. You can give some other names if you like. Now, if we are talking about equation, then roots word is fine. Minus b plus minus root of b square minus 4ac divided by twice a. I would be talking about ABC as real numbers, though it is not necessary. But I will be primarily concentrating on ABC to be real numbers. You also have a topic in your course called complex numbers, and that widens your scope from real numbers to non-real numbers. So this year you will be handling something like root of minus 1 also. So that's going into the domain of imaginary numbers, but I would be focusing on real numbers. So if ABC are real numbers, b square minus 4ac would be a real number. Discriminant is real. But still, alpha beta don't have to be real. Just because discriminant is real, alpha beta don't have to be real because of under root of discriminant. Now, discriminant is b square minus 4ac. If discriminant is positive, then you will have two values, minus b plus giving you something, minus b minus giving you something. So we say alpha and beta would be real. I'm assuming b and a are real, right? That's very important. Because if b and a are not real, even if this part is real, I can't say the whole thing will be real. If b and a are real, and if b square minus 4ac is positive, then you are going to get two roots which are different from each other. So we say two roots which are different, which are real, which are different. Real and different. So I'm clearly talking about ABC being real, that discussion. Now, if D is equal to 0, if D is equal to 0, then plus or minus signs don't hold any meaning. Minus B plus or minus 0, it's going to get you minus B only. So you are going to get only one value, whether alpha or beta, only one value. So we would say that the two roots are equal. The two roots are equal. Note that we are still saying that there are two roots. The basic rule is that if you have a quadratic degree 2, then you should have two roots. If you have 3 degree, you should have 3 roots. If you have 4th degree polynomial, you should have 4 roots. Some roots can be real, some roots can be non-real. Okay? So because it is quadratic, we are saying two roots. But if they are equal, then technically we won't say there's only one root. Loosely we may say sometimes, but actually it means that the two roots are equal. Two roots are equal. Technically that's all it means. Right? So real and equal. The third case, when D is less than 0 or negative. When D is negative, then you are having something like root of minus 5. Imagine if some number is equal to root of minus 5. Square both sides, y square is equal to minus 5. How can square of some number be equal to minus 5? We are talking about real number line. In real number line, square of any number can never get you minus on real number line. Right? So if D is negative, then you cannot have real roots. So then you have complex roots. Complex roots. Complex number is that number which may have such type of numbers called imaginary numbers. These are called imaginary numbers. On real number line, you cannot put a mark for root of -5. Where will you put it? It does not exist on real number line. But to deal with these numbers, you make use of a plane called Argand plane. And there is a topic which deals with these types of numbers called complex numbers. So if you get these types of numbers, then they are called complex numbers. So roots are complex, and obviously one will be obtained with plus, other will be obtained with minus. So complex, different complex numbers, different complex numbers. Different complex numbers, when I say one number is something like this, minus b plus root d by minus b plus root d, denominator is not important right now. In fact, I should just say something plus root d, something minus root d. Now, denominator is same for both. This part is same for both. Let's fill up those blanks now. When you use splitting, you find that this part is same for both. Note that I am talking about ABC to be real. That means b by 2a is going to be real. Of course, minus sign also real. So the two complex numbers that you are getting have the same real parts. Root d is the problem. Root d means root of -5 type of thing. So we say this is the imaginary part. That's where the difference is. And interestingly, you will find root d by 2a, root d by 2a. That means they are also identical. So the difference is only in plus and minus signs. Otherwise, this fellow identical to that. When you find such complex numbers whose real parts are same, and you will find this only sign difference for the other part, then such complex numbers are called conjugate complex numbers. Conjugate complex numbers. For example, 2 plus root -1 by 3. 2 minus under root -1 by 3. Look at these two. You will find this. If you ignore the sign, this, same. But the difference is in signs. Such complex numbers are called conjugate complex numbers. Complex conjugates means that the real parts are same. Real parts are same. Complex number has a real part and a non-real part. In these two twins, the difference is only in the sign for the non-real part. For real parts, there is absolutely no difference. So when you have such complex numbers, then you call them conjugate complex numbers. Okay? So in this case, where d is negative, then you have complex. They are different, and we prefer the word conjugate. Complex conjugate. Complex conjugate. That's a very important rule in in roots in mathematics, in roots discussion in mathematics, that complex roots are always twins. Complex roots are always twins. So like forces are twins, so are the complex roots, always, without exception. Not only for a quadratic, but for third degree polynomial, 4th degree, 5th degree, 6th degree, 10th degree, any polynomial you take. If there is one complex root, can never be 1. If there is one complex root, its twin must be there. 2. Complex roots always appear in pairs. Always appear in pairs. You can never have one and only one complex root for any polynomial, any degree. Now one more thing is that if D is a perfect square, something like 4, something like 9, something like 121, if D is a perfect square, then it means root D would be rational. If D is 4, root D is 2. If D is 36, root D is 6. If D is 121, root D is 11. Root D is going to be a rational number if D is a perfect square. So if D is a perfect square, then root D is going to be rational. So this implies that root D is rational. Is it safe to conclude that roots would be rational? Answer is no, it is not safe to conclude that. Why is it not safe to conclude that? Because of B and A. If I am getting something like this, minus B plus minus rational, whole divided by 2A. I have only said that A, B, C are real, okay? But I have not said that they are rational only, they cannot be rational. No such restriction till now. No such restriction till now. But for the fourth point, if A, B are rational, now then what would happen? Minus B plus or minus something rational. Minus B is rational, plus or minus some rational would be rational, divided by 2 will be, 2 is a rational number, divided by 2 would be rational, and then divided by A. A is rational. If A is rational, then that whole thing would be rational. So if D is a perfect square, and if A and B are rational, then it means that roots are going to be rational. So these are the 4 important points about the roots, nature of roots. If you have any question up to this point, then let me know. Proceeding further, again something that you already know. If we talk about this equation ax squared plus bx plus c equal to 0 with ABC being real, in fact this will hold good in any case. Alpha plus beta equal to minus b by a. This will hold good in any case. Alpha into beta equal to c by a. This will also hold good in any case. You know these results. Now you can get some idea about the signs of alpha and beta. If product of two numbers, you will find C by A. Suppose C by A comes out to be positive. If product of two numbers is positive, then you can say something about those two numbers. Either both of them are positive or both of them are negative. Likewise, if C by A comes out to be negative, then you can say that one of them is positive, other one of them is negative. Right? Suppose A and C are having the same sign and B is having the opposite sign. Then what can you conclude about the roots? Both roots will be positive. Yes, that's right. If A and C have the same sign, then it means alpha and beta is going to be positive. That means both can be either positive or both can be negative. But we have one more information. B is having the opposite sign. If B is having the opposite sign, then B by A will be negative, and negative into negative is positive. That means sum of 2 is positive. These were the two possibilities. But if sum of these is positive, then it means the only possible thing is left is this. Any question about this? Let me know. Case 2. A, B and C have got the same sign. First root is negative, second one is positive. Looks like you will have to check your working. That answer is correct. Both are going to be negative. Now, how? Let's see. All the three have same sign. That means C and A also have the same sign. If C and A have the same sign, then you can have only two cases. Both are plus or both are minus. So one plus other minus is not possible. Now, if B is having the same sign as A, then it means B upon A is going to be positive. Positive into negative is going to be negative. Sum of 2 is negative. So how can both be positive? If you have any question regarding this, let me know. Okay, now think about this. Supposing A and C are having opposite signs, what can you conclude about the roots? One is positive, other is negative. Yes, that's right. One is plus, other is minus. Whatever. Now, if there is any question about the third part, then let me know, or I will move on further. I think I'll be taking problems now. Looks like no questions. Let's start with an easy problem. X square plus 5x plus 4 equal to 0. What is the nature of the roots? Nature means you have to tell real, non-real, equal, non-equal, rational, irrational, all those things. I'm expecting a complete answer. Real, equal or not equal, real, complex, equal, not equal, rational, irrational. Real, distinct, rational. Yes, that's complete. That's the complete answer. Real, unequal, rational. Okay. If there is any question regarding any part of it, then let me know. Let me just discuss that rational part. D is given by b square minus 4ac. And you can see that it is 3 square. So D is a perfect square. And look at others. Others means what? Others means A and B. Look at A and B. Are they rational? They are rational. If A and B are rational, and if D is a perfect square, then the roots must be rational. So real, rational, unequal. Discuss the nature of roots. After this, I will increase the difficulty level. So a complete answer is expected. That includes rational, irrational, whatever. If it is complex, then don't say real, rational, irrational. If it is complex, then just say complex. With complex, you can possibly attach complex conjugate. That's it. Answer is real, distinct, irrational. Check the rational irrational part again. Real, distinct, irrational. Yes. Any questions about this? Any part of this? If you have, then let me know. Fine. So let's increase the difficulty level. That's right, you got it quite quickly. If anybody would like this to be discussed on the board, then raise your hands. If there is any specific question, then let me know the question. Okay, here we go. They are equal. Equal means d equal to 0. That means minus 2 square ac plus bd square equal to 4 times a square plus b square, c square plus d square. 4 is positive, you can cancel it. Open the whole thing. Twice a, b, c, d. Right side also open the whole thing. A square, c square, a square, d square, b square, c square, b square, d square. This will go, and you get a square, d square plus b square, c square minus 2 a, b, c, d equal to 0. Which formula would fit here? That's it. So first minus second whole square. I hope it is done now, and we can, yes, and we can move on. And now you can raise your hand if you would like this to be discussed on the board. Okay, here we go. For this, roots are real and unequal. Now that means D is greater than 0. So 2c whole square minus 4 times AB is greater than 0. 4c squared minus 4AB greater than 0. Dividing by 4, c square minus AB greater than 0. This one should be useful to us while handling this. Non-real complex. Now we want D for this. When you look at this, c square minus AB is greater than 0. When you multiply by minus sign, you get AB minus c square. But when you multiply by minus sign, this sign will reverse. Right? That means AB minus c square is negative. 8 times negative is going to be negative itself. That means discriminant is negative, and therefore the roots are going to be complex roots. Any questions about this? Let me know. This one is slightly more challenging. Or I should say, much more challenging. You very well know the procedure. It is the algebra which you need to apply to get the result at the end. It is algebra that you need to apply. And I can give you some clue. Cannot be different if real means Supposing you somehow get this type of result. Let's say minus x minus y whole square is greater than or equal to 0. X and y are real numbers. Okay? Now, x minus y whole square cannot be negative. Cannot be negative. There is a minus sign outside. This fellow cannot be negative. There is a minus sign outside. So minus multiplied to something which can never be negative, can never be more than 0. Isn't it? More than 0 will never work in such a situation. When we say greater than or equal to 0, there is or hidden. This or is hidden there. The roots will be real if discriminant is greater than or equal to 0. That's the meaning of it. If greater is not possible, then the only possible thing can be equal. Cannot be different. Equal. You have to prove that it must be equal to 0 only if roots are real. When you solve this, you should get something like this that I have written here. Something of that type. Right? So, taking that clue, the challenge would be to get this type of some positive character here. It does not have to be x minus y square type. Some positive type of character is what you need. There are several positive type of characters. Maybe this, or maybe this, x minus y square, z minus y square, x minus z square. Some non-negative type of character should come. There should be some sign between the two. AC minus BD whole square, AD minus BC whole square. I think there should be a plus in between the two. That means something like this type of situation. One bracket square plus another bracket square type of situation. Okay, so if anybody is not able to get that form after simplifying D further and further and further, if you are not able to reach here, AC minus BD whole square plus AD minus BC whole square, then let me know and I will show it on the board. You can raise your hand so that I understand if you need help with that. And if you have got it, then you're okay, fine. So let me show how to get that. If real, that means this. So b square minus 4 is c. 4, this. Now we can divide by positive number. Dividing by 4 is allowed. and then we open up the whole thing. Now the key step was this step, breaking 4 into 2 pieces, 2 plus 2. So you have twice a square b square c square d square minus a4 c4 minus I would prefer b4 d4. Grouping was also in fact important. This group with this b4 d4. Then another 2a square b square c square d square. Then a4 d4 minus b4 c4. Now I hope you are able to get that thing. Minus 4 times AC minus BD whole square plus AD minus BC whole square. Now after that, look at that right side. Minus 4 is multiplied to something which will never be minus. And right side is greater than or equal to 0. How can it ever be greater than? It can never be greater than. So to make it happy or satisfied, the only option left is to consider equal to sign. And the moment you consider equal to sign, it means D is 0. And if D is 0, then how can they be different? So they cannot be different. If they are going to be real, they must be the same. If they are wanting to be real, they must be the same.